Alright, let's jump into the lab to configure our EIGRP for IPv4 topology. Here's the topology we're going to be working with. First, we're going to configure EIGRP peerings between R1, R2, R3, and R4. And then we're going to advertise the local networks connected to R2 and R3. Here's what our base configurations look like. We're simply going to have each router create EIGRP autonomous system number 1 with the router EIGRP1 command. Then we'll assign router IDs, make passive interface be the default, add our network statements to enable EIGRP on our routed interfaces, and then we'll say no passive to the interfaces that we want to form EIGRP peerings on. And then finally, for the base configuration, we'll say no auto summary to disable auto summarization for EIGRP. Okay, let's start by configuring R1. We'll go to configuration mode, and then we'll enter the command router EIGRP. And if we do question mark, you can see that we have the option to configure it for an autonomous system number. We're going to use 1 for our AS number in this lab. Then we're going to give it a router ID, passive interface default, saying we don't want any interfaces to participate in EIGRP peerings unless we actually say no passive for that interface. Next, we have to add our network statements to enable EIGRP on the routed interfaces off of R1. If we take a look at those interfaces, starting with F00, we can see that this IP address is on the 172.16.1/30 network. So let's first say network, and then the actual network, which would be .0. Then we have to apply a wildcard mask. The easiest way to determine our wildcard mask is to write out 255.255.255.255 and then subtract our actual subnet mask from that value. So if we subtract our subnet mask from that, it'll be 0.0.03, and that's going to be our wildcard mask. So let's go back to adding our network statement with our wildcard mask. So with that network statement, we're saying that EIGRP is now enabled on this interface, and it will also advertise that network. But since we said that all interfaces are passive by default, and we haven't defined that interface as not being passive, if we run the command show IP EIGRP interfaces, we do not have any interfaces listed here. So let's say no passive interface F00, and now that we enabled it by saying no passive for that interface, it now shows up as an EIGRP interface. Next, we'll do the same thing except for our F10 interface, which is the 172.16.2/30 network. Now we should see two EIGRP interfaces. And there we go. So we have enabled EIGRP on R1's F00 and F10 interfaces. Next, we're going to say no auto summary. By saying no auto summary, we're disabling automatic summarization of networks for EIGRP. Most newer software versions have it disabled by default, but it's good practice to always add no auto summary to your EIGRP configuration. So do show run section router EIGRP, and here's our whole configuration. Since you have the idea of how to configure it, I'm going to cheat a little bit, and when we configure the other routers, I'm going to just modify R1's configuration in Notepad here. Alright, so the configuration is pretty much the same, except we have this additional network statement to advertise the LAN network 10.2.0.0. That's a /24 network, so it ends up being a different wildcard mask. and then no auto summary. Paste in our R2 script, run our verification command of show IP EIGRP interface, and we see we have two interfaces enabled for EIGRP, and we have a peer off of the F00 interface, which if we run the command show IP EIGRP neighbor, we see that we have a peering to the R1 router, just like we wanted. Let's actually hop over to R1 real quick. And if we run show IP route, we should see some EIGRP routes now. Alright, so here we go. We have this route in our routing table that has the D flag. If we look at our, code, if we look at our code values, D stands for EIGRP. Actually, an internal EIGRP route. So a route we learned from our local autonomous system. So there we go. And then you can actually also run show IP route and then EIGRP, and it will only show you EIGRP learned routes. Look at the topology table. So let's see, if we look at this 10.2 network we see that it has one successor with a feasible distance or routing metric of 156,160, and it learned it via R2, and R2's reported distance for that route is 128,256. We can actually learn even more information about the route if we do show IP topology, and then if we pick a specific route like the 10.2 one, we can find a lot of information here. So we can see that the minimum bandwidth in the path was 100 meg. The total delay in the path was 5,100 microseconds. And the originating router was 2.2.2.2. This is probably one of my favorite EIGRP troubleshooting commands because you really get to see what values were used in our composite metric calculation. Okay, so let's zoom through the rest of the topology and we'll configure R3 and R4 for EIGRP peerings. We'll paste that in. Make sure that our EIGRP interfaces are enabled. There we go, it already has a peer, I'm assuming with R1. See if it has any EIGRP routes. And it does. Modify our script for R4. There we go. So now all of our routers have basic EIGRP configurations and should all be peers. So let's run show IP EIGRP neighbor on R4, and perfect. It has two peers, one to R2 and one to R3. Okay, so we're learning all of our routes. Perfect. Now that we have our basic EIGRP autonomous system number 1 configured, we're going to configure R1 to advertise a default route into EIGRP. Once all of the routers learn the default route, we're going to go to R4 and manipulate its delay value on F10 interface to make it so that it prefers the path via R2 for the default route instead of having two equal cost routes in its routing table. So back in R1 here, the best way to advertise the default route with EIGRP is by redistributing a static route for the default route. So right now, if I look at my running configuration to see what static routes I have this static default route configured. If I go under my EIGRP autonomous system configuration and say redistribute static, it will redistribute that static default route to the rest of the topology. So if we look in R4's routing table, we see we have two equal cost default routes in our routing table. That's because it learned the same feasible distance from R2 and R3 for that route. So if we look at the show IP protocols output, by default EIGRP has the maximum paths of 4. That means it can install 4 equal cost routes in its routing table. Another thing you'll notice, we have this EX code next to our EIGRP code. And that means it's an external EIGRP route, meaning that it was redistributed into the autonomous system number 1 topology. And you'll notice that instead of an administrative distance of 90 for our internal EIGRP learned routes, we have our external administrative distance that we talked about in our last section, since it's a external EIGRP route. Let's look at the topology table again here. So you can see that now it says we have 2 successors. They both have the same feasible distance, and since we can do equal cost routes, we now have 2 successors for that path. Well, that's great, but now what we're going to do is we're going to change R4's F10 interface delay to be 100, and then that path will have a higher metric than the path via R2, so that instead of having 2 equal cost routes, we'll only have 1 primary route via R2 for our default route. To confirm what your existing interface delay is, if you just run the command, write out the whole command here, show interface F1/0, I can see that I have a delay of 100 right now on my interface. If this was in the configuration, it would actually be a delay of 10. So I'm actually going to configure a delay of 100, which is going to become 1000 in this output. Actually, before I do that, just so we can see what the composite metric is right now for that route. So we can see that the total delay is 200 microseconds currently via both paths. Okay, so let's go to interface F10, and I'm going to just simply say delay of 100. And now we have 1000 here. Let's run our show IP topology. So now we can see that the total delay for the default route learned via R3 is 1100 microseconds compared to 200 microseconds for the path to R2. So now when we do show IP route, we only have 1 default route installed in the routing table, because since we don't have 2 successors now, we only have 1 successor. It's only going to install successor routes in the routing table. So here, now we only have 1 successor because the path via R3 is now a feasible successor path, because it meets the feasible condition of having a reported distance that's less than the successor's feasible distance for that route. One trick you can do with the EIGRP, you can actually have EIGRP routers do unequal cost load balancing, and the trick is there's a option called a variance that you can see with the show IP protocols output. Let me find it here. By default, we have a variance of 1 here. What the variance is it's a multiplier for EIGRP metrics. EIGRP will take the variance value and multiply it by its successor path's feasible distance value. Whatever that value ends up being, is if there's any routed paths that have a metric that's lower than that total, then it will install those routes into the routing table as well. So let me show you what I mean here. I know it's kind of confusing by just trying to explain it, so let me show you. Okay, so right now we have a variance of 1, meaning that the variance multiplier is just times 1, so our variance total would be the same as the feasible distance. And the path to R3 obviously is more than that variance total, which would be this. So if we make the variance 2, that means that it would take 30,720, multiply it by 2, and then any paths that had a metric lower than that total would then be installed in the routing table. So EIGRP is just a way to kind of trick EIGRP into installing routes into the routing table that it shouldn't. So let's say you had two paths to a route and they didn't have the same metric, but you wanted to install both of them in the routing table, then an easy way would be to use this variance command. First, let's get our calculator out here and let's try to predict what this variance would be. So if we made it 2, take our feasible distance for the default route and times it by 2, that would equal 61,440. Well, since our feasible successor's metric is lower than the variance total, then it should become a successor and be installed into the routing table. So you just say variance and then a value between 1 and 128. We'll say 2. And look at that, we now have 2 successors because, like we just explained, the feasible distance times the variance is more than this path. So I bet you we have 2 routes in the routing table again for the default route. And we do, even though they're unequal cost. One more thing to show you here with the EIGRP. I want to show you the effects of having auto summary enabled on our router. So since we have what's called discontinuous networks here, which means that we don't have the same classful networks throughout the whole topology. So for example, the 10 dot networks sitting off of R2 and R3 are part of Class A classful network, while the networks between R2, R4, and R3 are part of Class B networks. That's a discontinuous topology because the 10 dot network is disconnected at some point in the topology. And what will end up happening is R4 will end up learning a 10.0.0.0/8 summary route from R2 and R3, and then it will no longer have the more specific routes that it would need to route to those networks. Alright, so let's go under EIGRP on R2, and we'll say auto summary, and we'll do the same thing on router 3. Let's go down to R4 now, and now you see that it's learning 2 10.0.0.0 summaries, one from each router. So you can see how the auto summary can really mess up your topology. R4 doesn't know that it should go to R2 for R2's 10.2.0.0 network, and the same for R3. So that's why it's always a best practice to have no auto summary. There are scenarios sometimes where it makes sense to just let auto summarization summarize routes for you, but most of the time it's best to manually summarize so you have control over the summarized routes in your network. Before we end the configure and verify section, there are a few more verification commands I'd like to show you. Earlier we used the show IP EIGRP interface command to see basic EIGRP interface information. We can also actually run show IP EIGRP interface detail and then the interface number to see information like if split horizon is enabled, as well as what our hello and hold time intervals are set to. Another great command is show IP protocols. And if we look at the information here, we have our K values, our router ID, as well as our current internal and external administrative distance values. That's it for the configure and verify section. Next, we're going to learn how to troubleshoot EIGRP for IPv4.